Welcome back. The excitement is building. Today on Pathogen Murder Mystery, we're going to generate some phylogenetic trees. So I'm going to step you through that. So just to summarize, because you might not be watching these sequentially, what we've been doing is there was an outbreak. We sequenced the pathogen culprit. And then we looked at the reads from the sequencing to make sure they were good, and they were. We ran a taxonomic classification on those reads using Kraken-2 to see if we could figure out who it was, and signs were pointing towards E. coli. We did genomic serotyping, and we found that it was a specific serotype, which was O104H4. We assembled the genomes, we annotated the genomes, we did some things to see if we were right, if it was E. coli, like we blasted the 16S ribosomal RNA gene, and that came up as E. coli, and we also looked at MASH, min-hash, to see across the whole genome how strongly it was associating with E. coli. And looking across all the bacterial genomes in the Bioinformatics Resource Center, BVBRC, and that was like a slam dunk for E. coli. We also last time generated some groups of genomes to use for a phylogenetic tree because you can't make a tree with just one thing. We did groups for things before 2011 when this epidemic happened, that were classified as O157H7 for that serotype that was common in Europe at the time. And also because we knew from the genomic serotyping that it was O104H4, we also made a group of that pre-2011. And then we made a couple of groups of those post-2011, so we could compare it to the past and then what it's been like since then. And so today we're going to generate some trees. Okay. What kind of phylogenetic tree should we make? What should we use? Well, we could make a single gene tree, and I'm actually going to step you through that. A lot of people make trees based on multi-locus sequence typing, which is MLST, and those are like 7 to 20 genes that people have used for a long time. People still use it, but to me, it speaks of more of a pre-whole genome sequencing era when you were limiting yourself to this kind of data. And then you can do one with multiple genes, which are generally the core genes, and that's what we're going to do today. And then the most powerful one, well, they're different flavors. You can have power in different ways. So single nucleotide polymorphisms or SNPs. And that's something you want to do when, well, you do that for viruses a lot, but when things are really, really close in the bacterial sense and you can't tell between them, that's often a good way to generate trees. So once again, we're going back to BBBRC because it's really easy to generate trees from there and also to view them. I think on the next episode, when we view the trees, you're really going to like it. So there are 3 flavors of trees that they have at this resource. You can do a gene or protein tree, and you can create a feature group, which actually I've already done for ribosomal RNA. Or you can bring in your own FASTA. You can have alignments or non-alignments. You can trim them, and you have different tree building algorithms that you can do. And this is pretty nifty too, which we'll step through, is you can add metadata that you want to visualize on the tree. So this, for me, is a game changer. Well, the tree itself is great, but what I used to do is have my tree, and then I would color it in something. I like to use Adobe Illustrator to show things. But now you can just see it in the tree. So it's a good way to view things. If you're working with viruses, you can do viral genome trees. And today, we're going to do the gene tree with the 16S ribosomal RNA, but we're also going to do the bacterial genome trees. And at this particular service, What this does is it takes the shared protein families across your group, and you can do up to, well, it says up to 100 genomes, but I've actually gone up to 200 genomes, so I don't think they know about this, so shh, don't tell anyone. So you go up to 100 genomes, and what it's looking for are a protein that's in the same family, and every genome in your genome group has to have one copy of that. And so it might use it. I mean, if it's got more than what you're asking for, like let's say you say, I want to build a genome with 20 genes, because you can go in here under number of genes and select what you want. Let's say you only want 20. And of the protein families that meet this criteria, let's say they have 1,000. So it'll just be some random collection of these 20 genes. But what it does when it has those things is it takes the nucleotide sequence and it also takes the protein sequence. So to me, this is like a SNP tree often is the most powerful, but this is really powerful. This is like bumping up against that level, and it concatenates all those things together and builds the tree based on that. Remember those groups that we created? A single genome does not make a phylogenetic tree. Sometimes it's really hard to find things to compare, or you don't even know, you can't figure out what to do. So I tried to show you in the last episode easy ways that you can sort through data and find that. This is so exciting. Let's go build some trees. So first, let's do the whole genome trees. So I'm going to click on Tools and Services, and remember, I'm logged in right here. You see, it looks just like me, right? That little avatar. I think that it's the spitting image of me. So this is me. It's my workspace. These are all my jobs. You can see I use it a lot. And we're going to go into phylogenomics and click on the bacterial genome tree. Now I had my mystery gene, mystery. So there are my mystery genome. I add that in. And now the first group, I want to do 157H7, 1940 to 2010. So I'm going to add that in. You could tell I've built these trees before, right? And I know because it's all E. coli, and I know that 100 genes, I'm not going to get good support values on. So I'm going to bump this up to 500 genes. Now, here are the numbers that you can choose. And these trees run pretty quickly, and these trees run forever. Generally, we have the default at 100, because that's usually enough for any bacterial genome. But because I'm digging deep within E. coli, I'll do 500. And if I didn't like it, I'd go up to 1,000. But I'll put it in 500. We're going to run it in the pathogen murder mystery. And generally, I just take something like this, put it in my output name, and I'll concatenate mystery on there so I can see. Now, one of the reasons to do this, remember, is that originally when they had that polyvalent serum, when the kids came in that were sick and they were trying to see what kind of E. coli it was after they figured out it was E. coli, so they inoculated the bacterium into these sera from what was being commonly seen in Europe at the time. It didn't agglutinate anything, and they knew it was something different, and then they looked at it on a tree, but we'll look at two and see if it's different. So let's look at the metadata options. So we click this down arrow here. A lot of this is set because it's bacterial and viral. We're only doing a bacterial example, but I want to get rid of the strain and subtype because those are more for bacteria. These are things I often use, but I can go here, and some of the things I really like is host common name. So you can paint this onto the tree to see who it came from, and collection year. This is important for us because we are looking at pre-2011. We want to see what years these are. And then geographic group, this will give us a broad analysis of if it's Europe or Asia or North America, and then the isolation country. Move on over, and you notice you have to click on this, but the button is blue, so I can submit it. Bing. And it's submitting the tree job, and then it says it's been submitted. Okay. I'm going to teach you one of my favorite tricks. Don't tell anybody, or actually tell everybody. I've got this here, and this page is already loaded. I've loaded it up with all of this stuff. Let's add in another group. Let's do the O157H7 after 2011. Add that, and I'm going to call this O157 all mystery. And then look, I can submit it here. I don't have to go into the trouble of adding these again and again. Okay, now I want the O104 before the pandemic. Add that guy in. Just call it that. I copy and paste that, put that there, and also put in that my mystery friend is in there. Submit that guy. And then let's look at it afterwards too. After 2011, add that one for all mystery. Submit that. And now, just for fun, let's put all the groups in. So 157 early, and there it is. Sometimes I forget to click it, so I want to make sure I got it after. And there it is. And then I'm going to say all with mystery, and then submit that. All right. So I've got a number of jobs off and running. And I asked you to deny that this was really easy and a very easy way to submit a phylogenetic tree. I don't do command line. You bioinformaticians out there, I bet this is even easier than that. Okay, so we did that. Another thing I did was create a feature group to do a gene tree of this. And let me just show you briefly how I did it. I went into my workspace, I went into genome groups, and I'll just show you on one of them how I did it. Let's get a nice big one. So click on that, and I want to see those genomes, and I want to go into the features. Remember when we did this before and got the 16S gene for an individual genome? Well, this is bringing in all the genes for all the genomes, and look how many across all of these 23 genomes, there are this many genes. Well, let's open the filter here, and I can scroll here and click on ribosomal RNA, and there are 3 flavors of that, and I know that in this resource it's called small, I think. Yes, so here's all the 16S for these. And I was just filtering on that. Oh, and there's 112, but this is a gene tree. That's okay. So I'm going to click that in, and I'm going to create a group of this, a new group, and I'll call it 16S rRNA with mystery, because I want to add in the 16S from my mystery genome as well. So this is one group, but you're going to say, hey, wait. This is just this O157. The mystery one isn't here. Just wait, I'll show you. Let me learn you how to do it. So I'm going to add that, and it has created that group. And then I go back into my workspace. I click on my genomes. I click on my mystery pathogen. I go to genome. I go to features. I click the filter. I go to ribosomal RNA, and there he is right there, my 16S. And look at this. I haven't shown you this before, so pay attention. Going to click the group, and it's going to go into an existing group. And sometimes I have to do this because it's not showing me my feature. There. Now let's see. There we go, 16S with mystery. So I add it to that. So it added something in. You know, it's like your shopping cart. Of course, we're all going through the grocery store, shopping for sequences for ribosomal RNA of different flavors. And so from different aisles, you can grab it and put it all into the cart. How cool is that? So now let's do a gene tree of that. So I click on Tools and Services, and I go into Gene and Protein Tree. And because it's 16S, which isn't translated into a protein, we've got to keep it at DNA and not protein. So it's a DNA, and we had our feature group. There it is. And I'm just going to put that name in there. No, it's not blue. Why? Because I have not added the name of the folder. So now it's blue, but I want the same metadata fields so that I can show you how awesome this looks. And I mean, you better have like smelling salts because you're going to be so excited by this. I think you might even faint. So I can add the host common name. I can do the collection year. I can do the geographic group. And I can do the isolation country. And there we go. So we've submitted a ton of tree jobs, both whole genome for the bacteria and gene tree for the 16S. And because I want to show you what the difference is, if you look at a single gene, can we really look at one gene and is it really going to tell us a lot about a particular genome? Or it's better if you use more and do a whole genome tree. So that being said, in the next episode, we're going to look at the trees and interpret them. And I know if this is the last thing you're doing tonight before you go to bed, I feel bad for you because you're probably going to be so excited about this that you can't sleep. So it's best to maybe watch this in the morning so you can binge watch the next one because it is going to be good and I'm really excited to show it to you. So I'll see you next time. Bye.